going to be doing now is drilling this out, elongating the hole so we can make a pocket so we can have access to the bolt that's going underneath there. As you can see, we've opened it up with the die grinder. So what we're going to be doing now is machining a tube up out of this same 1-inch schedule 40 stuff. So picture the socket as the tube, so that's going to go in there like that. And then we cut it off and then weld it up, then it's a fully sealed off tube. It's solely for aesthetics, instead of just having a big hole like that and just having a nut sitting in there. It just doesn't look, you know, like you've done a proper job. So it'll be a quick little job. So now we've got to throw this in the lathe, turn down the diameter so it's not so thick, so then we can slide it in there. And this is the actual socket for the nut we need, so we've got ample room on the inside diameter for the spring washer and the socket to go over, so should all work out quite well and look really tidy. As I say, this is probably a half an hour muck around job doing this, but the end result is a lot better than just having a big blank hole like that. All we need to do now is mark that out, cut it off, weld it in, and it's all done. And it's a nice pocket. There's probably people out there thinking, why didn't I just run a straight across there to another straight and notch it? Anyone can do that, so there's nothing unique about joining tubes like that. Why not make it like this, spend another half an hour making it look nice, instead of just having two tubes, like, yeah. Making a bit of progress now. So what we're going to be doing is mounting this main crossmember bar to the mounting plates here. So we'll tack it on for the nail and then put it back in the car and make sure everything's going to clear and we're going to be good to go. We've also, as you can see, we'll finish this off. So all we did was tap the sleeve in there, welded it around, cut it off and then linished it. There's one little undercut on this one here, so I've got to put a bit of a little spot weld on there and we're good to go. So let's tack it all up and then throw it in the car and see if it's all going to work out. What we're up to now, we're going to be making some pedestals for the engine mounts. Be some simple little brackets up there, across there. Machine some engine mounts up there, and also some bushes for the subframe bracket there. Here goes the pieces all cut out now. As you can see, we've got a nice chamfer. What we used there was this little pneumatic chamfer tool. You can find them on TradeMe, they're about $100 or so. They use 2 carbide tips. The only downside is no one in the country has these tips, but no doubt when the time comes, you can always rotate them. You've got 6 sides per tip, so you can always flip them around, but no doubt you'll be able to find a machine shop that we should be able to replace those later on down the track. But check this out. Like, it's hard to see, but if you saw that in person, you'll swear that that's a milled piece, because the chamfer is so perfect. There's no way you can do that by hand. And if you get these laser cut or water jet, you're only going to get the perimeter. They don't cut on the angles as well. But yeah, it's really hard to see it. Hopefully this will focus. You know, I can't really tell, but yeah, beautiful chamfers on there. And how we get this edge here nicely smooth and true, just run it on the belt sander there and linish them. So there's nothing worse than when you see something made and someone hasn't finished it off. They'll just, you know, use the bandsaw, they'll use a cut-off wheel or something. You can see all the grind marks and they're all uneven and wobbly. So yeah, look at that, nice piece. And so no one will see it, but at least we know it's been done properly. I jumped the gun, I forgot to record what I'm up to, so I'm up to the last subframe bush. That's what they're going to look like. They still all need the back chamfer done, and also the recess done on the back side. So the reason why we have this recess here is to allow for the deviation on the chassis. So it doesn't matter if you have like a nice flat surface made into another nice flat surface, but I know those chassis rails in that car, just how all things are, they're never perfectly flat. So we allow for that by having a little recess there. You're going to have a better seating face than having, say, this completely flat. Then you might have a high spot in the middle, so then it can exaggerate a rock. So yeah, that's the reason why we put that recess there. It's not for looks, it's simply there for a purpose. But this bit here is definitely for looks. You know, you might as well put a bit of shape in. There's nothing worse than just seeing a straight cylindrical bush in there. So these are definitely for looks, but that side there, it serves its purpose. We have the subframe bushes all machined up now. Both sides are all done. As you can see, we've machined up the stainless steel inserts. Nice press fit in there. Good to go. Look at that. So they're a nice press fit in there, and they're basically size for size for this 10mm stud, so there's no play in them. So that's that basically done now. So we're gonna start looking at machining up the pivot shafts for the lower control arms. So I've decided to run with some 4140. It's it'll be a great material. You don't want to use anything stainless on steering components or anything like that. This is a real strong material. It's real hard wearing. Basically, it's what else uses it like? You know, you got pump shafts, motorcycle axles use 4140. There's heaps of type of stuff. So in those demanding conditions, I think this will be the most appropriate material to use. So we'll cut it to length, and what we need to do now is turn down our diameter. So the first one will be for the threads. So we're gonna do some thread cutting, then we'll step it up. That'll be the shank for the bush. And then thirdly will be the bigger size that will go through the cross member and we can weld it on. So let's start machining. Here's the pivot shaft all made now, M16 thread on it. Here's an old nut we found lying around. Goes on sweet. Didn't have a die nut to run down it, but didn't need one in the end. Just use a thread file and she's bang on. So all we need to do now is machine this here to length. And that's basically it. Good to go. So what we've done now, we've used the mag base drill and used the hole saw to go through there. As accurate as a hole saw can get, so I measured the hole in the end and it ended up being 0.3 oversized, which is to be expected. So we're 24.3 now, 24mm cutter. So what we're going to end up doing is machine the outside diameter of these to 24.3, slide them through, job done. About to turn down the diameter now. Here goes the pivot shaft, so we'll give it a test fit. Obviously it goes that way, but we'll see how it fits. Beautiful. Zero tolerance, doesn't move at all. That's how you want it. So what we've got to do next is we've got to drill through. So we'll drill through the end there, come through there, halfway point. We'll drill, so drill down there, drill that way. So it'll be basically like a 90. And then we'll drill and tap the end so we can put a grease nipple in there. That way there we can grease this point here. We've just marked our ears out for the engine mount. So how we got the measurements, the 6mm width is the same as the pedestal here. And then obviously 6mm half, that's going to be a 30mm radius. So 30mm there, put our dividers on, scribed it out, and that's how we got that. And as for these quarter ones, we just had these sitting here, so just trace around them that way, and on the back side that way. So that's how we got all of our measurements. We need to cut it out now and basically drill the 2 holes and done. Tabs are now shaped out, so what we're going to do now is finish them up, make them nice and true. Here's the engine plate all done now. Nice smooth radiuses, follows the same profile as the front cover. It's a real nice finish, like you'd think that was a polished finish, but really all I did was cut it with the skill saw, filed it all by hand, and then ran it over with a Rolock, and that's how we got that nice finish. As you say, you'd think that was a CNC part, but it's all just done by hand, just out of a flat plate. Even these are all done by hand. You would have seen on the last video anyway. But what we're about to do now is put it onto the bottom of the car, onto the bottom of the sump, put the cross member back in, and then start getting ready shortly to start making the gearbox cross member. Here goes the basic componentry of this engine mount setup. So what we're going to do now is bolt the cross member in, and we're going to bolt the plate to the bottom of the motor. As for the engine mounts, I'm not too sure if we're going to use those or not. We're going to use them as the dummies for the now, and if I need to shim it up to raise a bit of height, then we can do that also. So let's bang it in the car. For the final weld on the engine mounts now. So here's our datum point, because this is where it goes onto the chassis. So we've got 0 degrees there, and we're going to make it 5 degree angle backwards. Here it is all welded out now. Do the trick, no undercuts anywhere, so that's the main thing. So what we need to do now is put our axles in, pivot shaft, slide in there, go through there, into that one there, weld them on, and then once we've done all that welding there, we can then crack test it. So we're going to do die penetrant style this time. It'll be ample. And there we have it. Obviously, apart from the pivot shafts, we also just need to finalize our height for the engine mount there, and that's it. Then also we just need to trace around there to shape those so they look a little bit nicer. All in all, pretty happy with how it's turned out. It's taken a while, but to replicate another one of these, you probably do it in 8 hours easy. That's machining everything up. So there we have it. So here we have the engine sitting in place now. Still got to determine how high we want it, but that's pretty close. Give or take 10 to 20 mil or so. But if anything, it's going to go a little bit higher, but nonetheless, that's sort of how it's going to sit. Now let's throw it on the ground and you'll sort of see how the whole hidden engine mount system is working, and let's see how much clearance we've gained from making this crossmember. Now the engine's sitting in place, that hidden engine system is working a treat. Check that out. Looks like it's just floating there, and that's the whole purpose. To be able to see it from this angle over here, you got to come all the way back down over here. Pretty horrendous angle. To be able to finally see it there. And as from the front, you have to come pretty low down. That's basically touching this panel here before you can see it. And you think about it, once the belt goes on, it'll be basically sort of like that, and it'll cover that as well. So all in all, very happy with that. It's looking really good. That's exactly what I wanted, just to make the motor look like it's floating there. Small price to pay. We've got the one tab there, but that looks a whole lot better than the big factory ugly setup that's out there. But nonetheless, I haven't measured or anything yet, but when I make the extractors, we might come across the front anyway to get the even length, but yeah, we'll sort of work that out as we come. But there we have it. Looks like it's just floating.